Okay, we should be recording, so let's get started. And thank you so much, everyone, for coming.
Thank you, Sarah. And we just came over from the e-NABLE Town Hall, so we're excited to hear from two groups presenting. Rotary continues to work with Arizona State University engineering projects and the community service EPICS student teams at the Center for the Handicapped in Sri Lanka. We were very excited to hear about that. And I think we have another group also presenting today, and excited to learn from both of them. John, would you like to kick us off? I'm really excited to hear what you've been up to.
Yeah. Hi, Ian. Hi, everybody. Yeah, thank you for the introduction. Yeah, I'm just looking at the names and looking at the people that have just started this semester. I know Amanda's here, and she's actually one of the tutors at ASU, and she was going to explain the EPICS project from ASU. I can't see is there anybody else from ASU here? Oh, John is here. He's another tutor. Oh, Sarah. Okay. Sarah, are you? Right. Yeah.
Yep,
Okay.
I'm here. I'm enable events.
Right. Okay. Right. Does anybody want to sort of start tell people or share with people what we're doing?
I'll go and give a brief overview of what the EPICS program is for those that are not familiar. My name is Amanda Minutello. I am one of the faculty associates that teach the component section of EPICS, which is Engineering Projects in Community Service, where the students are working in collaboration with your organization. EPICS is a student-based human-centered design process course that allows students to work on real projects and make an impact and apply their classroom knowledge in a way that allows them to get technical experience from beginning as a freshman. So the teams on the phone today are comprised of various engineering disciplines from all different years of school, trying to develop prosthetics for students or for children. And through the process, they follow the human-centered design process. So they evaluate stakeholder requirements, user needs, design requirements, and then do a few iterations of a prototype before delivering and developing the product for their client, essentially. So that's the overview of the EPICS program.
And is this a credit-based, like a capstone course?
It's similar to a capstone, but it allows freshmen, sophomore, juniors, and seniors to participate. So it's a capstone style experience, but they can do it as early on as their first semester of college. So it's a really great way to help shape the future of our engineering leaders, as well as give them hands-on technical experience to help them figure out what they enjoy about their major, or perhaps figure or experience something not related to their coursework. So when I was a student at ASU, I participated in the program, and I've been involved in the program for the last 9 consecutive years. So it's a really great program, but it allows students to, like I said, work on projects related to their major as well as projects not related to get a larger breadth of engineering experience.
Okay, thank you, Amanda, for that overview of the EPICS program. We've got to Louth Rotary and Sri Lanka, Centre for Handicapped in Sri Lanka, are partners to the two EPICS teams represented here today. I can see Kelly, and she's one of the leaders of the team. Do you want to sort of highlight, Kelly, what you've been doing? It is only the start of the semester. We've only really got the meetings going in the last week or so, so it's quite early days. But the advantage of actually working with ASU is that the projects from last year, the momentum gained in last year's projects, are carried forward onto a new semester rather than the semester sort of ending and then you having to start again, or somebody perhaps leaving and maybe they've got the material all squirreled away in their own personal drives. This advantage is that we've got that continuity, and that's what we really like, because we do work with some high schools, and they do have this problem of certain super keen people leaving, and then they leave it behind, they go to university, and then the schools are left. And if there's not a continuity, sustainability sort of element to the projects. So we're really actually, that's why we were attracted to ASU in the first place, because they had such a strong EPICS program. We also did a review in the summer, which was pretty good over the summer break. The staff contacted us, and we did a face-to-face review on a virtual review of what's gone right, what's gone wrong, how can we improve, and they did that with all their EPICS projects. So, but we did it for two of our clients and found it very, very useful. But that's perhaps enough of me. Let's hear from, we've got two teams. We've got, I know Kelly, we had the meeting earlier in the week. Is that right, Kelly?
Yes, that's right. We
Yeah,
met on Tuesday morning
yeah. Do you
or
want to?
Tuesday afternoon.
Yes, indeed. Yeah. Well, the thing is, what we meet is very early Arizona time, so like 7:30 or even 8:30 in the morning, and that works with London time, which is sort of mid-afternoon, and it works with Sri Lanka, which is well into the evening. So we've got this sort of 3 to 5 sort of window, which is a reasonable time for everybody. Although, as I say, it's a little bit early for the likes of people in Arizona, but it's working. It's working. Kelly, do you want to sort of share where we're up to?
Yes. So currently, our team is called e-NABLE Design, and we are a stage 2 team. We started last semester, and we were designing and brainstorming all these different ideas, and we finally chose to work on the hand lock to make sure the fist is locked in place when you bend your wrist, and also a flexible thumb so we can increase grip strength. And also, we will be working on a CAD design for this moving semester. And we will be 3D printing, assembling, and hopefully testing for next semester. And that is the progress we have made currently.
Yeah, and this team is actually working on the client is a young girl. I'm not quite sure her precise age, but I think she's under 10. But obviously a factor we've got to take into account is the rapid growth of children and the actual how the semester how the prosthetic will actually cope with that, so it doesn't become redundant like an item of children's clothing. They can outgrow these things quite quickly, and therefore we don't want to be in that situation. So that's pretty good.
What an amazing collaboration across the world. And
Yeah,
John, you're sort of in the middle here with the matchmaking. And
yes.
when they meet, are they actually meeting with the client on Zoom as well? So you're able
Well,
to get feedback immediately?
Yeah, that's a good question. It was actually raised on Tuesday that they'd like the contact with the parent and the child in this particular case. Um, and it's something we've got another meeting tomorrow afternoon. It's quite intense at the moment. We've had a few really sort of getting things moving, but we do have to cross the sort of the connectivity issues that the family might have, because it's all done through the Centre of Handicap, which is in an urban area, but sometimes the clients are in remote areas and connection issues are a problem. But the team on Tuesday did raise that very question of actually talking face to face. It might mean using a translator or even using Google Translate or something, but at least there's the children or the child in this case and the parents can see who's working on the prosthetic for them, which is a
Really
great
cool.
um,
And then I'm curious about a little bit of nuts and bolts, like what tools are you drawing in and what type of measurements do you need from the client once you have the mechanism defined to fit it?
Yeah, we used, I think it's an e-NABLE YouTube video that actually we presented to the Centre for Handicaps, and they actually used that to send over the measurements. What one thing we did come up against, well, one thing that came up on Tuesday was actually providing CT scans from the hospital, nearby hospital, because we ran into an issue last year of shipping. It was becoming the costs of shipping from the States to Sri Lanka were really silly, really. And also, if it actually literally goes by ship, it can take a long time rather than air freight, obviously. But they came up with the CT scans, but the Centre for Handicapped have come back that the cost is quite high from them because basically they wanted both hands and arms scanning so they could see the fully functional hand and arm, and then they can computer model to actually get the actual new designs. So we did think last year of sending out a cast and actually doing sort of very mechanical sort of approach and shipping
Cool.
it out, but it did run aground at the end of the last semester. So we're trying to think of new ways around that.
That's really interesting, getting the shape data across the world.
Yeah, definitely. But we're not quite sure at the moment. It might end up as a funding issue. Well, it is a funding issue for Sri Lanka. So we need to sort of progress that a little bit. But we're moving in the right direction.
No, and it
But
sounds like you have the two extreme spectrums from like taking a DICOM file of medical data and getting it
yeah,
into a mesh
yeah.
to working with a physical object that you ship across the world and then digitize.
Yes. That's the idea. And what one of the groups hopes to get the prosthetics actually out to Sri Lanka before the end of this semester. They've given themselves rather an aspirational target there,
Yep.
but there was a lot of materials testing. Last year we had a group that had a design group and a materials group, and the materials group did a lot of testing to actually improve the basic Phoenix hand. We're talking about going from there and adapting that hand is how we're not gone from a blank sheet of
Yep.
paper, but obviously we've got to suit the two clients. Now I'm just looking
Yep.
around. Is the other group represented here? The one that's working for it's Jennifer and Mackenzie. I can't see Mackenzie and I can't see Jennifer. But that group is linked to John, who's a member of the staff at ASU. Is there anybody else from that group here represented? I'm not quite sure. Sarah, which group are you in?
I'm on the Tashmi design team as well.
All right, okay. And Aaron, you're in the same team, yeah? Yeah, we've got a big representation of one group here. I don't know. John, did I sort of interrupt you there? Are you able to provide a bit of background on the other group?
Yeah, I can talk a little bit about where it's at.
Yeah.
For reference, I'm not actually ASU staff. I'm an industry mentor. So I have a lot of years doing various kinds of program starters as a mechanical engineer, and worked in a lot of high-tech industries, including at one point body implants. So I do have some experience to support this team. I work with 4 different teams, all completely different projects. This group is further along, I think, in some senses than the other group, but doing a prosthetic hand for a young boy, same situation, trying to get more accurate details of the amputation configuration all the way up past the elbow to, well, the hand. The amputation is partial hand, but they're looking at both a hand prosthetic and a prosthetic that goes further up the arm to give them better attachment and control. They had started previous semesters with a an open source 3D printed hand design. And this semester, they're trying to improve the strength, improve the um, ability to grab things and the tactile feel of it, and also very important to the user is making it look more natural and less like a robotic hand. Um, so they're doing a bunch of different things. The team is, split up, chasing different angles of that. Um,
That's really interesting. Those are often two opposing design constraints, making it mechanically functional and stronger while making it look a certain way that the client wants it to look like a normal upper limb.
Yeah,
that's true.
Could you talk a little bit about how they oppose each other and what the team is thinking, how one direction might guide the other direction?
So they're looking at putting some kind of a glove over it that will look more natural. They're working on how to attach silicone materials to an ABS printed hand. Um, they're working on different configurations of 3D printed parts to make grabbing easier than the open source design they started with. It has some. That design is made for a kind of generic amputation full hand. So they have to adapt the attachment for the individual. They have to adjust some of the shapes where there's like a very flat palm that makes it hard to grab things. Finger lengths we found are maybe the length of the elements of the fingers are a little bit off, and that needs to be adjusted. We talked about features like, do you want a fingernail printed into it so they could, just trying to open a laptop computer, it's nice to put a fingernail between them. So we looked at different features in addition to material strengths, the strength of the cords that they use to move the fingers, the angle of the thumb, could you, is there benefit, and could you actually make the thumb close separately than the other four fingers? So they're looking at how to make a stronger grip as well as just be able to hold up a good amount of weight.
Very cool. I'm wondering too, how you project manage that. And we have a team here that has a bunch of people. Like, how do you organize and divide the work into these very different verticals?
Well, it's student led. I mean, I'm an advisor, not leading anything. And this is my first semester. I just started a few weeks ago, and so I've only been with them a couple of meetings. Um, so they get a lot of good instruction from the teachers on how to organize. There's a lot of process available to them of, here's a template for statement of work. Here's a template for schedule. Here's the, each week they get some instruction. This is a class. They have teachers, they have student aides who can help them in just understanding how to run process of running a program. And they break up, divide and conquer. They will break into individuals or teams of two to go take on various aspects of this in parallel. And for instance, one is working on improving CAD skills and cycling the 3D printed parts. Every week I show up, they've got a new set of 3D printed parts they're assembling with slight tweaks. So somebody else is working on how do you bond silicone to ABS, and I pulled in a plastics engineer that I worked with for many years to give them some information that they could dig through and go experiment with. They also have campus resources that they can go pull on. There's labs at ASU and professors who have facilities and experience they can all grab. So the student, in this case, Jennifer, is very well organized and a really good leader for her age.
Very cool.
Yeah. And I know John's quite new to this, and it's great he's on board with the expertise. This just one slight correction because I worked with these guys last year. This is an adult client that we're actually working with. He's male adult, and he works in some quite heavy industries, and therefore the strain on the actual hand is considerable. So that's why the group, and to
Yeah.
be fair to them, that they're not represented other than John today as the advisor. They're not represented because we talked. The majority of the students here today are from the group who met on Tuesday, and it was only raised to come to this meeting this week. So
Yeah.
obviously, we might well have the other team might
No,
have.
it's super cool to hear a work in progress too, early stage, early in the semester, and what you're thinking about and where you're heading.
So,
Yeah, I mean,
John, that's really interesting. The only thing I've seen of the client here is a hand photo,
yeah,
and the other pictures I had seen of potential users were all children. So
right, yes,
I
yeah,
hadn't realized this was an adult. So thank you for letting me know that.
And it's
that's
really interesting what you bring up about the heavy use of the hand. I'm wondering if the students here can talk about how you do stress testing. Like, do you put it on an Instron? Do you think about fail state, about like how it's going to break, when it breaks, and what the limits are?
Are there any students from Kelly's stroke Pax's group that can share any materials testing details?
Sure, I can talk a little bit about that. My name is Sarah, and I'm the prototyping lead for the Tajmi design team. As we're going through some of these tests, one of our main things this semester is working on that grip strength. So first, we're trying to test just regular functionality of, will it be able to pick up a book? Will it be able to pick up a pencil? And then as we go throughout the semester and kind of narrow in on our final design, we will do some of the more stress testing things. Toshmi's only 6, so she's not going to have as demanding of needs for the kind of structural integrity and like the strength of the actual material. But we can 3D print in different infills, so it'll be like a thicker or thinner amount of filament that we have to work with. And that might be one of the things kind of in our final stages of design, testing to see what amount of infill and what maybe supports we have to add inside of the prosthetic to make it stable enough for her to use.
Yeah, it's complete contrasting client because going back to advisor John's group, he also does workouts in gyms and stuff. So again, you're talking about weights and that type of thing. So the discussion certainly earlier in the week turned to their lifestyles. This young girl's lifestyle, and maybe she does swimming or sort of plays tennis or whatever outside of school, and the
Right.
perception would have to be geared up to take into account her lifestyle, and the same way that the other group has to take into
That's
account
the occupational
that.
therapy task. Like, what
Yes,
are the daily tasks they have to achieve?
yes,
Really interesting. So you've sort
yeah,
of got like three converging big areas of design to focus on: the occupational therapy task, the adaptation to the individual's physiology, and then the material performance of the actual designs. I'm curious too if we could go into some of those other details, like what software are you drawing in?
Sarah
And
might
what
be.
type of machines are you fabricating? You've mentioned ABS and silicon, but I'm curious about like what your software and hardware looks like that you're fabricating with. I think that would be helpful for other schools to hear.
Sarah or Kelly could probably answer that.
Yes. Currently, we are using Fusion 360 to design a CAD model for the 3D printed hand. And for 3D printing, we just use the Fulton services that's provided to us through the EPICS program.
Cool. And so when you're using Fusion and you're using one of these designs from the e-NABLE hub, do you get a native Fusion file, or are you pulling in like a mesh file and modifying it, or are you starting from scratch? I'm a little curious how you're using the open source hardware design.
We were planning on using the open source as a base model, and we will be adding our own designs on top of it. And we will also be uh, editing the measurements based on what Thorini tells us on, well, tomorrow actually. Because we need to have some updated measurements because Tajmi is a growing girl. And we were also thinking of adding, well, implementing like an extendable part of the prosthetic
Yep.
so she can use it in the long-term run.
And John had mentioned that you're following that e-NABLE sizing tutorial, which I think looks at like a couple orthogonal views, which then you can like overlay in the CAD from like different perspectives. Are you taking a technique like that for measurements?
Uh, we haven't actually gotten too deep into it because last meeting was mainly making sure everyone's on the same page because we
Yeah.
have such a large team. We have a team of 11 people,
But
and only 3 of us are returning, but a couple of members do have Epics experience, so that does help a lot. But you brought up a good point, and I think I will bring that up to the team. Thank you.
no, it's interesting because I think John has highlighted one of the big issues here about how do we convey shape data from a very remote location and what's significant. And I think that's like a really interesting design question. Like you've got a lot about the occupational therapy task, which grounds you, but then the nuts and bolts of how you size is really a big challenge.
And it's more than just shape data. Um,
There's the compliance, right? So that you want it to be like something like rigid where the biological material is soft and soft where the biological material is rigid, or some element of compliance like that to think through.
Well, that, and you also have the, what actual motion and strength do they have in what aspects? For example, there is some semblance of thumb on the person we're dealing with, and we don't know range of motion or strength in that. So is that available for some type of activation? And how much, we have to accommodate that and how it fits in, and is it, do we alter how the open source uh, 3D printed hand works, having that available to us, that thumb motion. So we need to understand that as well as just the physical dimensions.
So I'm curious about how the student teams are approaching that design challenge. How are you going to get a feedback? How are you going to design a feedback loop to tell if that's working?
I think our team is trying to send iterations on a regular basis, as they make
prototyping a physical version and sending it to the client for feedback.
Yeah, that's the plan.
Very cool.
The difficulty with that, of course, is it's actually the distance in terms of the time lag. So that's part of the thinking of the CT scan and more a focus on computer modeling.
Yeah.
Back in Arizona with
that's interesting. So you could take the underlying shape data and do some stress modeling in the CAD tool and look at some simulations of force. It's an interesting approach. I wonder, could you build a physical rig too to do some testing in the lab about force or direction?
That's over to the students and John, I guess.
I'm so sorry to say this, but
oh, go ahead.
Oh, I'm so sorry. I do have to leave actually because my lab starts very soon.
Fascinating discussion, though. I can't wait to see where you go with this. Definitely come back and keep us updated. And as we can see anything about your designs or process, I'm sure other educators who watch this later on YouTube would love to see your drawings, your iterative prototypes, like your process. I'm sure you do a presentation along the way, but any of that behind the scenes info would be great to see.
Of course. It's been like wonderful being able to listen and share between the e-NABLE teams. And it was so nice to meet you, Ian Roy.
Very nice to meet you, and I hope to follow along as this develops.
Yes. Thank you again.
Thank you, Kelly.
Have a nice day.
Cheers then. Bye.
Bye-bye.
Right, Sarah, did you want to add anything to that? Because Kelly was a bit sort of had to go there, or Aaron, do you want to add anything onto what's already been said?
I can talk
Go ahead,
a
Sarah.
little.
I was just going to jump in
sorry.
quick and say that the teams, as a part of the class, do have it's almost like a midterm presentation, but it's about 2/3 of the way through the semester to give them enough time to get the ground running and get some designs done. So I'm not going to put this on the student spot right now, but they could always prepare to present that presentation in one of your calls in an abridged version if that's
That
something
would be amazing. I think that we
Yeah.
encourage a lot of teams to show unfinished work and to critique it. Like we can do a run around the room. And I think even the teams meeting together here could learn from each other a bit.
Yeah. So we can work on arranging that. I can talk to you guys in class about it, as well as the other e-NABLE team that's building the adult male prosthetic. So I can work to get that scheduled with you also.
Super cool.
Yeah, good.
And John, so we've talked a little bit about the three sort of design tiers of challenge, from adapting to physiology, thinking about occupational therapy, thinking about materials and design. I wonder too if there's any thought about how to beat this time lag of shipping. Are there any fabrication facilities, like could you ship a machine overseas and then your digital file moves so much faster, or is that too much of a challenge?
Yeah, I mean, we did think of that, of 3D printing equipment, for example, and putting it into a school. You know, we have actually discussed that into a high school, because you could then get sort of the wider Rotary family involved, the interactors. You know, they're 12 to 18s in schools. So we did talk about that, but it didn't really progress that much. But obviously, if we can get the actual parts manufactured, or the hands manufactured out there, and then the students in the high schools can learn how even if it's a basic, start off with a Phoenix hand, and let's just like learn how it works, how it goes together, etc. And then they can go into the more higher level skills of talking to the client, and what we've been just talking about now. So we've not touched it on it this semester, and to be honest, what we're trying to do at the moment is actually really energize, you know, the two teams that we're working with, to really get some momentum going, and work. You know, that shipping issue was a big issue at the end of last semester, because you guys went into the summer break and then the clients just left, you know. And ideally, it's better to go into a break where the actual item is out there. Then the client uses it for a few weeks, or in summer's case, a couple of months, and then you get then you get sort of really good feedback. So that's what we were aiming for, but didn't quite happen last semester. So,
That's what a cool program, though. A win-win-win, and those feedback loops are so tricky to get good, useful information back.
Yes, yeah, indeed, indeed. What we've also been doing is focusing on the communication channels, because the people in Sri Lanka are marvelous in terms of the English on their emails and so on, and marvelous, you know, in terms of these calls. But sometimes from both ends, the students from, you know, the US point of view, and the clients themselves, can be a bit hesitant over sort of that communication. So Rotary's been trying to sort of smooth the communication, and sort of have an input there of getting designers and makers, in this case the students at ASU, matched with the clients, and a bit of a sort of a matchmaking service, in terms of, because there's a lot of need for prosthetics, and the Sri Lankans really do appreciate these prosthetic developments, because there's no way that the families out there are going to be able to afford commercial designs. So that's the whole beauty of taking e-NABLE's philosophy, if you like, you know, an approach. One thing I didn't mention was the cultural aspect. I don't know whether that fits into one of your categories, Ian, but
Yes.
the skin color was and the so we've been looking at latex covering, things like that, but the latex covering wouldn't work for the guy who's doing a lot of heavy work. It's just not going to stand up. But we're looking into pigment color and so on. But the families, there's a very much a cultural pressure to get the hand looking on or the arm looking as normal, if you like, as possible within the environment. And because that the families are very conscious that their children or their relation has this need, this disability, if you like, and that's very important to get that right. As I say, I'm not quite sure which category that would fit in, or whether it's
it sounds like that, like the social integration issue is a whole separate vertical that's often like at odds with the mechanical performance, and then how do you balance the two is a really interesting design challenge.
Yeah, and the Jennifer's group and Kelly's group are also looking at actually putting some sort of metals in there to actually strengthen it even more to sort of supplement the existing largely PLA or whatever the material they're using. So they're not going as far as we had a client, which we didn't move forward in Louth in the UK, who we were looking exploring sort of motorized elements because that child had sort of a partial hand, if you like. So, but we never moved that forward. But in this particular case, it's a combination of materials that we'll be looking at, I think. Yeah.
And that pigment question actually drives material choice to some extent. And that's part of why the team's looking at ABS. They can get a much better control of that, and the physical structural parameters of ABS work as well.
Yep.
Yeah. Okay.
I wonder if there are any other questions from people on the call. We have some folks that haven't spoken yet. Wanted to give an opportunity for any questions while the group is here. I see Chris, Xavier, Mai, and Jonathan. Mai, yes.
Sorry, it's May, actually.
May, sorry.
I actually, this is the first time that I've joined a call, and it's because I have a small group of high school students, and we're really just trying to figure out whether we can participate in some meaningful way. I feel like this conversation was interesting, but maybe still a little bit over my head in terms of like what would be involved. So I was just wondering if you have any tips as to like how we can kind of just understand the basics of what we would need to do to set up a club here.
Yeah, and I can share what we did in the UK in terms of high school level, because we actually linked with a school over in Georgia, and they provided as a sort of kickstart to a project. They shipped us some hands over that the students in the high schools sort of put the hands together and learned how the hands, as I mentioned earlier, were constructed. Then they used the likes of Tinkercad to actually model some gadgets, if you like, and learn about the actual process from that point of view. And then they produced their own hand on the 3D printers and actually assemble their own hands. So they were sort of learning how the prosthetics worked, if you like. So I don't know if that helps. That was sort of like 12 years old, 12 to sort of 14-year-olds.
So did sorry. Would you recommend like using just starting with the kits that are available online and proceeding from there first?
Yeah. Take the open source. I'd recommend taking the open source material. I think we just took the Phoenix hand as an example,
Right.
and actually printed those off. The students then learn about the printing. They learn about how it's assembled. They learn about how maybe to vary it slightly. You can sort of start to sort of move around on the actual settings in terms of the scaling and so on, because that gets a little bit more tricky then. So that's a starter. There's a school in Georgia, in Canton, in Georgia, called Sequoia High, and they got a robotics department. And they led the way for us, and they did really well. But the downside is the school in the UK has lost the enthusiastic teacher, who's unfortunately become ill and long-term sick, and they lost the actual student because they graduated and actually went to university. So at the moment, they've really suffered from a lack of continuity planning. So we're trying to get that back on board. But that's some of the things we've done in the UK.
I'm also happy to share an assignment that we do in our Intro to Engineering course that I designed here.
Okay.
And I put it I put a link to it there, and I can show the assignment briefly and what the student work looks like. So if you're curious, this is when we started. So we are about to launch our first engineering class at Brandeis. So we're an R1 liberal arts research institute that has about 3,000 grads and about 2,000 grads, 3,000 undergrads. So just under 6,000 students total. We're a small, scrappy institution, and we don't have engineering. So in 2023, we launched our first engineering course. And we were looking for meaningful challenges. And this is like an intro to design course. So it's a CAD and CAM course with a capstone project. And this is just a 2-week project for 18-year-olds. And essentially, people work in pairs to 3D print the Phoenix hand. We started with V3, but we've moved to V2, back a generation. And we've done that because we want them to fit them to themselves a little more. And it's not about, it takes away the complexity of solving occupational therapy tasks or fitting to individual physiology. And instead, it's a critique of open source hardware. And we're just trying to use a bias towards doing something in the space of helping people with open source hardware. So we've tried a couple different versions of this. This was our first version. And it's really about every engineer has to consume documentation, but also produce documentation. So it's a critique of the open source hardware documentation is what the student is providing. And so just a 1 or 2 week sprint where they run their own prints, but they also have to look at a video guide and a text guide and say what works better on each. And eventually they adapt something and release their own guide. So this is like a breadcrumb leading to something.
Great, thank you. That sounds helpful.
And I think for me, that was the magic of finding bite-sized pieces of e-NABLE to use in courseware, was like, what are the real like teaching goals that we can use a bias towards doing something positive around? And I can show quickly, like, this is what it looks like when we're in that course. So this is in the classroom, that assignment, that orange piece of paper being executed, students working in pairs, to both set up the CAM. We recommend 150% scale for your first assembly, and it's really learning the platform. And then what they produce from this is a critique of documentation. So in this particular course, all of their assignments are submitted as a website that they edit. So they're like creating portfolio work where they critique this stuff. And then ultimately later in the semester, they're creating an open source guide where they're releasing those files back out. So this was taking something off the hub that was made to hold a hockey stick or a lacrosse stick and adapting that mechanism to hold a bicycle. And then their work product is really like some Thingiverse files and a how-to tutorial.
Great, thanks. Thank you for sharing that.
And I think this group is always really excited to geek out about pedagogy and how we can take the huge assets of the e-NABLE community and turn those into interesting coursework, which is why I was sort of interested in framing this project as the verticals and how the team works and how assessment and reporting works. And Mai, what are you thinking about integrating this into? Is there a particular student course or club, or like where your interest hooks into the institution?
Oh, actually, this is a 3D printing club, so
cool.
It's just an extracurricular, and one of the teachers here had been involved in e-NABLE prior, and she brought this idea over to the students. I think they're really interested in doing something that has a positive social contribution. But the club right now is just focused on learning like CAD skills. And I
Totally.
think for them to be able to produce something that would be helpful to others is something that's very motivating to them right now.
This is a super cool topic, and we just talked about this at our town hall like an hour ago. Jonathan and Sarah were there. I put together 3 links I just sent. So Makers Making Change is another asset that we use a lot that has this open source assistive hardware. Often when you start thinking about making prostheses and getting feedback from a client, you realize what they need actually is a better doorknob, right? It's problems with their built environment. No human can be truly disabled. We have poorly designed environments that humans have to interact with. And Makers Making Change has a huge repository of things like that. Video game controllers, kitchen appliances, things to adapt to handles and pushes and pull interfaces. But a new thing that we just saw today, I hadn't seen this before. I don't know how long they've had it. They have a call to action there, that Makers Wanted link, where they have clients asking for small things to be fabricated. And I just sent this to our 3D printing club an hour ago, being like, we should definitely hook into this. It's a great club base because they're scoped fairly narrowly with a clear ask. And some of them are just fabricating an off-the-shelf thing, and some are like adapting it for a particular use case.
Yeah, that's a great thing to consider. Thanks for sending that.
The other thing I say that anyone who wants to work with e-NABLE, we saw another one of these requests today. There's a lot of groups that want to make parts and send them somewhere to make them useful. There's not really a mechanism for that in the e-NABLE community. And there's another sector that wants to make hands not fit to an individual and send them somewhere useful. And again, they don't really fit individuals. So I think it's so cool what this group is doing actually with the fit and function, which is the missing piece, I think, in a lot of e-NABLE fabrication. But that's not to say that a generic hand can't be useful. One thing we've been trying to do in this assignment, we make about 10 hands a semester that are not fit to an individual. But there are maker spaces around the world we've been trying to send them to as touchstones, or like a thing you can show a client. Like, we could make you something like this. Here's the menu. And it's like the off-the-shelf version that then can start the conversation about getting excited and adapting it to their use. So if you do make generic hands, you could find a makerspace somewhere that could use them as a menu of offerings. And the other thing that we've been trying to do with these are, like, can we use them for brake testing, material testing? Like, is there something else you can learn from? When we're building these for an assignment, I often tell the students to make it to fit their own limbs, however they are. Like, can you take a Phoenix V2 and fit it so that you can use it, and then live in it for an afternoon, live in it for a day? See if you can develop empathy for that use case. And if you have like traditional upper limbs with no upper limb difference, if you have trouble using them, imagine someone who has limited mobility using it. They would have even more challenges potentially in that design. And we moved from the V3 to the V2 because the V2 has a hook that you could fit your fingers through. So if you can size it for yourself, I think that's a great intro activity for like a 3D printing club.
Okay, great. Thanks. That's helpful to know. Is there, what would be the how do we go about finding individuals though who, once we're ready, how do we go about finding individuals who we could actually work with more closely to customize a hand?
So you can work through the e-NABLE Hub, and Jonathan is doing a lot of the badging on there.
Mm-hmm.
And if I could summarize the process, Jonathan, I think what you would do is you would first make a generic hand and then upload a video of it moving. And then John would give you a badge, and then you can use the hub as a matchmaking service. It's very hit or miss. It's very hard to find clients that will give you constructive feedback over time. I think what John has built with the Rotary and these relationships to international organizations is a much higher barrier, much more useful use case. But we don't see as many groups that have boots on the ground, but there's more and more happening, and a lot of them are talked about on the hub if you post there. I don't know, Jonathan and John, if you would characterize that differently.
No,
I think you summed it up really well.
Mm-hmm. Yeah, indeed, I agree.
So the first thing would be picking one of those recommended devices and then putting it together and making a video of it moving, which would then unlock the next level of posting and matching with a client, which often when our club was doing this, they would send 50 messages to get one client. So I think John's bridge into a client where the students can hit the ground and they know they have someone to work with, that's the whole barrier of the current matching system.
Okay, great.
And
Thank you.
the other thing is, the highest bar for this e-NABLE community is always to make useful things for people. But that doesn't always mean fabricating the part too. Like one thing my group's been working on is this link I just put in on the NIH 3D Print Exchange, which is aggregating the designs from the hub into something with more searchable metadata. So developing the metadata schema. If you're looking for an accessory to a hand, has someone already made it? And how would we sort and search for it? And like these designs that Sarah and Aaron are making, can you contribute them back so that other people can build on them? I'm sure you're already encountering the challenges of like, there's no standard file format. Often parts are their locked final output. They're the mesh files, not a parametric solid model that you can actually change a parameter in. One of the big challenges when you scale these hands up and down, often the screw holes also scale. So then your hardware changes. That's a huge challenge. So any of these little pieces, the club could also decide to focus on. I know there's like Eric Buvar's group is focusing on just materials testing, just like seeing how stuff breaks. We have a team currently looking at how we can make the screw holes stay the same when sizes of designs change. So you could also find like whatever the imagination of your community could focus on. That's obviously highest bar is making things for people, but there's other challenges. And one of the best ways, if your team wants to find an interesting thing, I think this meeting is great for hearing about educational use cases and then troubleshooting too, like troubleshooting both like curriculum, but also machines and technology and institutions and funding. Like I'll try to help with that in this meeting. The town hall every week is a read off of calls for help on the hub that have not been addressed. So Sarah and Jonathan, and usually a few others, including like John Schull or Jeremy, will run through all of the calls on the hub that week or the last 2 weeks and try to see who would be the right person to help with that. And if your organization can put their hand up, there might be interesting work you could find through that.
Is the town hall something that the students themselves could attend? Or
Totally.
It's during class hours though, right?
Yes, but it is recorded too, so you could always watch it on YouTube after. So these meetings are recorded. You could have them view it and try to pick up something.
Okay, great.
I record every meeting and then I always post the links underneath the event in the hub calendar. So I don't know, do you have a profile on the hub and are you able to access everything there?
Yes, I do.
Okay, great. So if you just go to the hub calendar for September, so there was a town hall meeting right before this today, as Ian has talked about, and I've already posted the link to that meeting right on the hub calendar. So if you just click on and open up the town hall, the recording will be right there. And I can send you the link. I'm gonna drop my email in the chat. And if after this meeting, if you have any unanswered questions, you can email me and I will send you.
Okay, great. Thank you so much.
We have about 5 minutes left in our regular meeting. Did that answer your questions? Give you some breadcrumbs?
Yes, absolutely. It's been very helpful.
I also wanted to open it up for anyone who hasn't spoken. Chris or Xavier, anything on your minds? Or Jonathan, if there's anything. I know Jonathan is like me, a 3D printing enthusiast who might see some opportunity in what we've discussed as well.
You know, I had some really interesting conversation with Anquan and John a couple weeks ago regarding like the direction that e-NABLE is going in a whole. You know, our structure right now, we have chapters all over the world, specifically in the US, especially lots of college courses and groups that are involved in it. However, with that NorCal e-NABLE group getting involved in the Uganda initiative, they found a way to connect whoever wants to be involved and print devices and send it to this, third world country with a massive need for them. It sounds like John Hodge, you guys kind of figured that out too. Maybe not necessarily on the scale of quantity wise, but I think that's kind of the next leap that e-NABLE can do is help set up processes to connect all of our volunteers with those people that actually need devices. So I love to hear about it. It's awesome. I've been involved in e-NABLE for a year and a half or so now, so it's exciting to hear, some people getting the devices that need them.
So there will be our next town hall is a week from today, just before this meeting. So it is 11:30 a.m. Eastern US time. And that's a half-hour rundown of things on the hub, which might be a good location. And we'll be back right after that, a week from now, to talk about more. Oh no, sorry. Next week is going to be the chapter leaders. Chapter leaders. We'll be back in a month.
Chapter leaders. Yeah. What day are you?
We'll be back October 23rd for education.
Okay, good. That's what I thought. Okay.
Yep. But next week is the chapter leaders. We try to keep our meetings to this same time slot on Thursdays. So there's something going on every week on this Thursday time slot. Thanks to Sarah organizing all of us. And in the meantime, if anyone wants to reach out on the hub, I'm always happy to geek out and troubleshoot courseware or machines or institutional support. I think that's really what our education meetup sort of triangulates on. How do we create something from nothing? Both the prostheses and the club or the course. But awesome to hear from the ASU folks. And John, I can't believe what you've grown this into. It's such a cool global relationship, and it takes a bunch of different specialities. So extra thanks to the students for leaning into this. It's really cool to see.
Thank you.
Thank you so much, John, and Arizona students. This was great. So
yeah, thank you all for having us.
And we'll share it with the other we'll steer the other group into the direction of the YouTube recording. I think that'd be a good idea.
Excellent. Good luck, everyone.
Okay.
And we'll